This class session number 1 is being recorded, and it will be available for you participants to watch at a later time if you want to study and see that. And that'll be posted on my TCC Blackboard in this Collaborate section and in the recorded lectures section if the recording works out fine. Okay, guys, I've got 9:03 a.m., so I'm going to go ahead and start the class session for today. This is the first class session delivered online for the Cisco Networking Academy course, Routing and Switching Essentials, ITCC 1440. I have a little whiteboard shared with you guys showing today's schedule. So the first thing we're going to cover is the instructor course requirement. I misspelled it. Instructor course requirements, ICR, or what normal people would call a syllabus. Okay, a couple of you guys have not been in this class before, so I'm going to go ahead and step through this and show you the syllabus requirements, the instructor requirements for this. Stand by one, I'll share that document. Mic test. Okay, good deal. Looks like we're getting something here. Sorry to blow you up that way. All right, so here is the instructor course requirements. I am Hicks, humble instructor. I will be your instructor for this particular 8-week course, which has been sort of abbreviated down to 7 weeks because we started a week late because everybody extended their spring break. Okay, so my office hours continue to be the same thing. Our class starts at 9 o'clock. And my office hours will be before and after this class. I also teach another Cisco class on Tuesdays and Thursdays. Okay, rolling down. I gotta roll it down over here. There we go. Go past all the mandatory stuff they make us. Okay, so under special materials, we will continue to use the Cisco Networking Academy website. All you guys have been placed on that particular website. This is the Cisco Routing and Switching Essentials course, which we're going to cover several things here that are, let me mention the Csun Exam, which is near the bottom of this paragraph. The Cisco Certified Entry Network Technician exam has been withdrawn from the general public, but all Network and Academy students can still take this test, the old ICND 1 test, Installing Cisco Network Devices 1 test, will be available under another test name and number from View, the testing provider, through July the 31st of this year. The Cisco Academy has changed, or rather the Cisco has changed the CCNA certification somewhat, and this went into effect at the end of February. And in the future, there's only going to be one test, whereas in the past, you were able to take the ICND 1 test and the ICND 2 test and together get the full Cisco certification. So now, after February for most people, and then after July 1st for everybody, even you guys, there will be one test to take, the 200-301 new test for this. Okay, so we're in an online environment. You can't come to campus. It's locked down. So we're going to be doing everything online using the Blackboard Collaborate software that allows students to talk to each other and to talk to us. A few of you guys, when you came to Blackboard and you went into the workroom, that's going to be, I have that locked out now for the class. I'll turn that back on when I'm finished with my class. Students can always meet with each other and chat and even talk with each other with their microphones in that particular area. For these class sessions, I have to mute all you guys' microphones because otherwise we get terrible echoes and feedback and things of that nature. So you can always send a chat message and I will be able to see that. So we'll talk about the grading scheme. To be successful in this class, take all the chapter grades, all the chapter assessments on the NetAcad site. Take all the, do all the laboratory assignments, which we're going to be using a packet tracer for that. For this semester, there will be no practical lab final. There will be no hands-on skills assessment. I've changed the grading scheme somewhat, and we'll see that in just a little bit. You still will have to take the final examination. Okay, here's the changes in the grading scheme. Now 50% of the grade is going to be the average arithmetic mean. That means we add up all the individual scores and divide by the number of tests, and that's your average for that. Of all the chapter exams, I think there's 10 chapter exams, 10 chapter assessments in this curriculum, and the final examination. So each of those will count, 1/11 of the entire score. And then 50% will be the laboratories that we have assigned for this particular course. So I've listed here below all the particular labs we'll be doing. And I'm going to go into a little bit later today into the packet tracer program and give you guys a demonstration of how packet tracer works. I'll step through the instructor lab that you guys aren't required to do, but you get credit for that just by being here. And then I'll show a little bit of the first required lab, the 2.2.2.5 IPv4 static routes, because that's got a serial port connection in it. And there's a little bit of a hoop you have to jump through in packet tracer to install a serial port onto your router, and I'll show you how that works. Okay, so ignore this part here. This is the old section of how we can calculate the grades. And then below here, I have the class dates, which are, since things are changing here, I put the first couple of things here. And then below here was the original scheme we would have gone through had we met in person. Okay, I want to stop sharing that. Can I stop sharing that? Oh dear. Oh, yeah. Okay, that's okay. I went crazy there for a minute, but I'm okay now. Okay, stand by 1 second. I'm going to bring up this other whiteboard. I have nine still. I have 9 students signed on right now. Okay, I'm going to go to the Blackboard and I'll bring that up and show that to you. Oh, I didn't have to do that. I could have done it this way. Okay, this is the main Blackboard screen for our particular class, ITCC 1440. I made some announcements here. Some of these you should have already seen, because when I created the announcements in Blackboard, I clicked the checkbox that said send an email to you. A couple of times it sent an email with nothing to you. That's Blackboard nonsense. I'm so sorry about that. It's my fault entirely. Don't worry about that stuff. So you know by now that all the TCC campuses are closed down. They're locked down. You will not be able to come to the Cisco lab and do the labs. We'll be doing all this labs as Blackboard, using the Packet Tracer program. And I'm going to ask you guys to simply download the Microsoft Word formatted lab reports and fill in the answers, and then save as that document with your last name in all capital letters, and then email that to me so I can put it in your gradebook. So you guys that successfully figured out Blackboard Collaborate, I have put a link here. This is a chicken and the egg problem. You should be here in the presentation to read how to follow the instructions to get into this presentation. So if you haven't read this, you don't know that I'm telling you to read this so that you can get into the presentation and sit in the first place. But we've got about 9 or 10 guys here now. That's good. We're doing all right. So I placed some documents here about why we're closed, what to expect when the class starts, and please read through those and see how that works. And I'm going to, let's see, oh dear, where did my thing go here? Oh, I got to exit the preview. Let's see, exit the preview. Go into the preview. Show the whole thing. Okay, so I've covered the announcements part. The grading criteria in Blackboard. Blackboard is not great code. I have to do some weird things. So the kind of numbers that you see in Blackboard as to the maximum number of points available, for example, it shows weird numbers for each lab and weird numbers for the exams and things of that nature. Please pay no attention to these numbers. I will post in the final few days of the course, I will post the actual exact averages to 9 decimal places, and those will be figured in and put into your Blackboard. I also will import all the numbers from Cisco Network and Academy for the chapter assessments and the final exam course, and I will place those in Blackboard, and you'll see an exact numeric value. 90 to 100, you get an A, 80 to 89.5, you get a B, and things of that nature. So also the averages that you see on the Cisco Network Academy site are not significant. Do not pay any attention to them. So that's the great thing. The course evaluation is a link to the WebAdvisor self-service student satisfaction survey that we'll ask you to do later on in the semester. There is another student satisfaction survey that Cisco Network and Academy does, which you actually must complete before you take the final exam. They force you to do that, so you won't give me a bad review after you take the final exam and then take the student satisfaction survey and you're mad at me because you didn't do good on the final exam. Course presentation materials. These are the PowerPoint presentations. I have got the how-to document, which is the chicken and the egg thing. You have to read that before you can come here and see me talking to you about it. And then I've got the PowerPoint presentations of the various chapters, and we're going to go very quickly through chapters 1 and 2 because we're a week late in getting going here. Here is the student lab printouts page, and what we're going to see here is I've got 2 very useful YouTube videos from network guru David Bombal that shows how to install the Packet Tracer software on a PC, which is this one, a Windows PC, and then he has also made a YouTube video on how to install the Packet Tracer on the Macintosh. The 1.1.46 lab, I'm going to step through this just a little bit later today with the Packet Tracer so that you can see how Packet Tracer actually operates. And then the 2.2.2.5 lab and 2.2.4.5 lab, I'm going to start the first lab, 2.2.2.5, and drag the devices in and show you how to get the serial ports configured in this, because it's a little tricky and not very obvious to you if you've never used Packet Tracer before. I've also posted some study guides. These are Microsoft Word-based documents on some various things we're covering in this course. Didn't I tell you guys that you can get a free copy of the Microsoft Office suite from the front page of my TCC Blackboard? You can get a free copy on up to 5 desktop PCs, Windows or Macintosh, and 5 tablet type devices. And that's free just because you're a TCC student. In the recorded presentations I'm going to be posting, I've also posted here, for example, how to install the YouTube, how to install Packet Tracer on Macintosh and Windows. I've installed some YouTube videos on the Chapter 1 and Chapter 2 video lectures, which I'm going to ask you guys to view on your own time, just try to catch up on what we're doing here in the lab. And we're in Blackboard Collaborate Ultra right now. When you click Blackboard Collaborate Ultra, you get the screen where you can join the course room. I have the course room locked right now so people won't go into it by mistake. We're actually in this class session one right now. Wednesday morning, we will have class session number 2. These will be recorded and will be available later, both in this section by clicking on the menu and choosing recordings, or in the recorded lectures session. And then I placed a discussion board where you can ask any questions, or you can simply email me, and I will respond to those as quickly as I can do. I can get to this with all this stuff we're doing today. All right, let's see. So I've covered my TCC Blackboard, and the next thing I'm going to talk about is the Cisco Network and Academy site. Stop sharing this. Share this. Share this. And hang just a second while I check on attendance. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, good. I got everybody recorded. Okay, so we've covered the TCC Blackboard. On the Network and Academy site, I've turned on all of the chapter assessments. There are quizzes in there. You don't have to take the quiz. You can if you want to. It doesn't matter whether you take it or not. It will not affect your grade at all. It won't be a part of your grade. The chapter assessments are on 24 hours a day. They're open book. And in this particular online session, due to the tough times we're living in, even the final exam will be open book. And I'll take those 11, the 10 chapter tests and the final exam, and I'll add those all together, divide by 11, and that will be the 50% of your grade for the test portion. So assignment for you guys to work on before we come back on Wednesday, please read chapters 1 and 2 on the Network Academy site. I have some recorded lectures on the recorded lectures part of my TCC on both those chapters. And get started in performing the labs 2.2.2.5 and 2.2.4.5 in Packet Tracer. Now, I'm a nice guy. I don't enforce I do not count off for late work, but we do have a final deadline here of the day of the final exam, which is around May the 4th, May the 5th, something of that nature, and all work will be due at that time. Now, I'm going to, let me see, I'm going to go into the instructor lab demo portion and show a little bit of this Packet Tracer and how you got to jump through some hoops to get stuff working on that. And let me share this lab that we're going to use here, just to see, so you can see what the front part of it looks like. This is the lab that's available in the student lab report section of my TCC Blackboard. And that's going to be this screen right here. And what I'm going to do is I'm just showing you what the front page of the lab looks like. This is the first lab, 1.1.4.6. This is not required for you guys to do. I always traditionally have done this as an instructor lab demo. Just since you've slept since then, you might remember any iOS settings. I'm going to go through and review this and go through some portions of this course. So I'm going to attempt now to bring up the Packet Tracer program and get this on here and see if we can get started with the Packet Tracer demonstration portion. So I'll stop sharing this. Share the application of Cisco Packet Tracer. Okay, here we are in Packet Tracer, and my mouse is moving. Oh, good. Oh, good. So in this particular lab, there are two PCs and a switch and a router that are connected together. So the first thing I'm going to do is I will drag in a router, and I'm going to use the 1941 routers, which is the router that we normally use. And I'm going to select, I did this, by the way, by default, it came up. These are devices that we can select, like network devices like routers and switches, host machines, and then I'll pull in a couple of PCs, fake PCs. This lightning bolt thing I'm going to use in a moment to drag the wires to simulate plugging in the wires in the patch panel on the back of the room and get everything connected. So I'm on the network devices, and on this portion down here, I put in a router. I'm going to put in the switch, the 2960 switch. So I'll put that there. And I'll blow this up in the limit so it's not so tiny. And then I'm going to choose the host devices section, and we're just going to put a PC in here. So I'll put PC A. I'll put it over here. And I'll put a second PC over here. Now let me see if I can make this look a little bit bigger so it's not so squashed down. And then in the front page of the topology, there's some connections between the various devices. And the topology shows that PCA needs to do some connecting. So this red jagged lightning bolt, I'm going to click on that. And I'm going to choose the third one, which is a straight through cable. And I'll click on that. And I'm going to click on the PC. And I'm going to choose the regular Ethernet port on the PC. And we're supposed to connect that to port number 6 on the switch. Okay, now I'm going to go down. I'll go down and click it one more time, and I'm supposed to connect port 5. Notice port 6 is missing now. I already assigned it. I'm going to click port 5, and I'm going to connect it to the G01 port of the router. And I'll click on the solid Ethernet straight through cable time, and I'll connect it from the Ethernet port of PC-B to port G00. Now we've got them all connected. Oops, bouncy mouse. Ooh. Okay, in the lab, on page 2 of the lab, it says part 1, set up the topology and initialize the devices. I have put all the devices in, and I've cabled them, and they're powered on automatically already in the Packet Tracer software. We'll show a little bit later on the second lab how you can power off a router. In order to plug a serial port into the router, you have to turn the power off, and I'll show you how that's done in this virtual lab thing. So step 1 says configure the IP addresses, subnet masks, and default gateways on both the PCs. So I'm going to click on the PC. This is similar to a Windows machine, but not exactly the same. So I'm going to go to the config and go to the fast Ethernet port and put in the static IP address for this PC-A, and that's supposed to be 192.168.1.3. And just like on a real Windows machine, when you push the tab key, it puts in the correct subnet mask. That's the one that's in the lab right now. We're not doing any weird stuff on this one. Where's the default gateway? Oh, it's on another link. So we're going to go to the settings button here, and this is where you put in the default gateway. He only calls it gateway. He should call it default gateway. He's just confusing everybody. Of course, the default gateway is for PCA is through the switch to that G01 port of the router, which is 192.168.1. It's in the table there as default gateway for PCA. Okay, and that should complete the settings. There's no save button or anything like that. Just click the X. Oh, I got to click the real X, not the one in the simulation. There we go. Okay, now if you float over PCA, supposedly when bring focus to it, there we go. And he tells you when you float over PCA, he tells you to set the particular IP address, 192.168.1.3/24, and the gateway is 192.168.1.1. So they're on the same network, and this should work okay. Now I'm going to do the settings for PC-B, the one on the right, in the same fashion. I just simply clicked on the device. Let me drag this over here where it's visible. Then I'll click the desktop. I'm sorry, the config. And this time I'll go ahead and put in the default gateway first, since that's the first screen. Okay, PCB is 192.168.0.1. And then I'll click on the fast Ethernet 0 port, and we'll put in the individual IP address. So that PC is called to have an address of 192.168.0.3. And it looks like that's good. So let's see, if I float over it, then it should tell me that it's coming off your screen a little bit, but it looks like it's okay. Now let's look at the switch. You notice on the front of this page that there's no switch configuration required. If you were using a real switch in a real lab with actual equipment, you would want to check to make sure that the switch has no existing configuration. So we're going to go into the command line interpreter here. Because remembering that the majority of these Cisco switches that ship into industry are never configured. Probably 75% of them go into smaller, medium-sized businesses. They just plug them in. So the ports are not down. They're not administratively down by default. They're not shut down by default. You just plug any active device into a switch port. The switch port will come up, and you can start using it. So for example, on this one, I'm going to do show IP interface brief, and we can see that, oh, well, that's terrible. You can't see that. Let me pull that up a little bit. Okay, switch port 6 is up and up because switch port 6 is plugged into PCA, and it's coming up and up automatically. Switch port 5 is not up and up. Well, that's because it's plugged over to the router port G01, and we haven't done anything to the router ports. And unlike switches, all router ports are administratively shut down by default. So we're going to need to configure the router, and when we get that up and up, this switch port will come up. So no VLAN assignment required in this particular lab. Some of the labs do require it. So let's check and see if this has any, two things we need to check for when we're using a switch. First of all, I'm going to go to the enable mode, and there's no password set. So I'm going to type the dir command and see there is no VLAN.dat file present. That means no one else has created a VLAN assignment with port numbers for this particular switch. And otherwise, we'd have to delete that, the delete VLAN.dat file, enter command to make sure the switch is cleared before we continue with it. Otherwise, this VLAN.dat would be present here, and you would see it present in the file system. The other command we could do is there an existing startup configuration present? No, there's not one here. Good. This switch is totally erased, and we can use it. Okay, we don't need to look at it anymore. Okay, I'm ready to go into step 2, which is configuring the router. So I'm going to click on the router and ask it to bring up the CLI, and then drag it over here so it's on our shared screen. And let's see if it's possible for me to make it a little bit wider here so it's not so scrolly. Now, when a router comes up, and also switches do this as well, they usually have some type of dialog that says, do you want to go into the initial configuration dialog? And that's usually a pretty good indication that there's no existing configuration in the device. Now, on a switch, that's safe for you to assume there's no previous configuration on it. You still need to check for the VLAN.dat file. In the routers, you don't have to check for that. So just seeing this one here should be a good indication that there's nothing there. I'm going to simply answer in or no. and we get the initial prompt of the router. But just to be sure, how can we check for sure? Show the startup configuration. There's none present. None has been present at this device. So step 2 tells us to go into the privileged exec mode, which I did by typing enable. If I wanted to go back to the user exec mode, I would type disable. I'm going to type enable, go to the privileged exec mode, and then I'm going to go into the global configuration mode, which is configure terminal or config T, because the first thing he has told me to do in this lab procedure is to give it a host name. And I agree with that. I like to give them host names right off the bat first, so that you won't get confused as to which device you're looking at when you're using terminal programs. So the host name given here is R1, and notice the prompt changed immediately to R1. The next command he recommends is no IP domain lookup, which is a great command that if you mistype a command, you're not stuck in like a penalty loop for about 3 minutes while it looks up your misspelled command as if it was trying to do a DNS lookup on it, and where there's no DNS servers in our labs. So I'm going to type no IP domain lookup. It's supposed to take it with or without the dash, and this one's taking it. I'm going to skip this security passwords command because I'm not going to use his weird passwords. I'm going to use the passwords that God intended us to use, the easy passwords, Cisco in class. Now, I'm going to drop out of the user exec mode because of the configuration mode, because I want to do something here. I want to show the running configuration, and we've done some things here. We did hostname R1. We did no IP domain lookup. The other lines in here are the default lines. We don't have to worry about them. If I ask it to show the startup configuration, I still haven't saved it. It's not in there yet. I would have to do copy run start, or copy, let me do the whole thing, copy running config, startup config, and that would save it to the destination. That would save that to the startup configuration file. And now when I do show start, there's our configuration that is saved. So normal Hicks rule of how often should I back up? And my normal answer to that is as often as you care to, or as seldom as you dare not to. So if it gets power turned off or something, if you backed it up, you don't have to start all over again. Okay, the next step on the little sub part 2, step 2, sub part F says assign this weird password as the encrypted password. I ain't going to use his. I'm going to use the one I remember. So back to the configuration mode and enable secret class is the word we use. If you put a space after the class and press the enter key, the password is now class space, and you won't be able to get in. So press enter right now. And then we're going to assign the console password. I'm going to use the standard Cisco one instead of the weird one that he made up. So line console 0, password Cisco, and then the command login enables this to be saved as the login password. Now he also gives the example of the exec timeout command. Exec timeout. Normally it's about, he says use 5-0. That's the normal 5-minute timeout. If you fall asleep or you go for lunch and you leave a terminal open, no one else can come up, because after 5 minutes they'll be logged out and they won't know the password. Okay, I did log in. I did log in. Oops. There we go. Now the next command is interesting. Logging synchronous. Logging synchronous is a command that the Cisco annoyances that pop up on the screen, like if you type no shutdown, and it chops up the next line after about 3 seconds. You're tapping the next line, it chops it up. This will prevent that from happening. So you can put that on. You can put that on your console port and the other ports as well. If we want to be able to, now this takes care of the console port, the baby blue console port on the device that you would be plugged in when you start doing the lab. This is what we're essentially attached to right now on the packet tracer program, is the console port. And then we want to be able to allow people to get into the machine once it's, this is out of band management to the console port. We want the people to be able to get into the machine in band through the Ethernet connections. So I'm going to type the command line ETY 0 through 4 and do the same thing. Password, password, and login. And now people will be able to telnet into the device from another location. Now there's another password in the lab I'm going to skip called service password encryption. The problem with these passwords is this. I'm going to go and do a show running configuration. I'm going to skip down to those passwords that we put in. They're shown in plain text. Password Cisco. Password Cisco. If you were doing a show run on the screen or you had this typed up, printed out, anybody could see that. So another good recommendation, a good practice is use the command service password encryption, and that will slightly modify these so that they're not so difficult to see. Now, the enable secret password, we took care of that. When we said enable secret password instead of enable secret class, instead of enable password class, it encrypted it for us. So it's safe. We don't have to worry about that. Okay, back to the prompt for R1, and the next thing he's going to have us do is I'm going to skip the banner message of the day and go straight to the Ethernet G0/1 connection. And we're instructed to go to the configuration mode, configure T, and give the command of an IP address. Oops. I have to say interface, gigabit Ethernet 0/0. And now I can say IP address, and it's supposed to be 192.168.0.1 with your normal subnet mask. And we have to type it. You can't type /24 here. And I'll activate it with no shutdown. And then I'll go to interface gigabit 0/1 and give them an IP address. I'm skipping the description. 192.168.1.1 and /24. 255.255.255.0. And then I'll do no shutdown. No shutdown. So that should be activated. Let's check our favorite little command, show IP interface brief. And we can see that the 2 gigabit Ethernet ports have the proper addresses, and they're up and up. I'm going to skip the clock command, but I will do the copy running config startup config command and save this configuration to the NVRAM. Now, he asks a question, what would have been the result of reloading the router prior to completing the copy run start command? Well, it would have had whatever was in there before, which is out of date, or maybe the nothing, and it wouldn't have started properly. So if the router was reloaded, power on, power off, or somebody type reload, or it crashed or something, it wouldn't have the up-to-date configuration in it. Cisco iOS does have the convenience factor, kind of similar to when you quit a Microsoft Word document and you haven't saved it yet. It prompts you, did you want to save the document? If you try to reload the iOS command to reboot the router, and there's an existing configuration that is not currently backed up, he'll give you a last chance to save it again. Okay, step 3, we're supposed to verify network connectivity. Let's see if PCA can ping PCB. So let me see, refresh my memory as to what those addresses on the PCs were, and then I'll bring those PCs up and we'll see how PCs work. Okay, I'm gonna click on PCA. We opened this up before to do the configuration. I'm gonna go to the desktop, and I just want a regular command prompt. So it kind of looks a little bit like for Windows machine. Can I ping my own darn IP address? I'm PC 192.168.1.3 is my, oops, just typed it. I can ping my own IP address. You should be able to do that. Can I ping my own default gateway? Wait a minute. Is this configured properly when I type ipconfig? Yeah, looks like my default gateway address is 192.168.1.1. 192.168.1.1. Can I ping my own default gateway? Yeah, I can. We're doing baby steps here, guys. Now I'm going to see if I can ping the other default gateway for the other network. And then we'll see why. I can. Wow, it's working. Baby Jesus. Okay, now we're going to ping PCB. And bad magic, it's not working properly. Is this the ARP request timeout thing? Yes, yes. My heart stopped, but I'm okay now. And why did that first request time out? Why was that delay? The ARP procedure had to rectify this correlation between the layer 2 MAC address and the layer 3 IP address when I asked to ping that layer 3 IP address. I knew the layer 3 IP address, but I did not know the layer 2 MAC address. So my PC had to send out an ARP request saying, calling all stations, if your IP address is 192.168.0.3, PCB's address, please send me back a little helpful message telling me what your MAC address is so I can put this ping request in the Ethernet with your actual MAC address, not the broadcast address, and you can reply to me. So now when I repeat it, it's fine because ARP is held in memory for, I don't know, 2 or 3 minutes. And it'll be in there. So we verified network connectivity. And I'm going to skip the secure shell thing and go to router information and review some of these show commands. So I will close this PC and bring up the router again, and let's bring it over where it's bigger on our screen. So show version is a command that repeats all that stuff that scrolled off the screen when you first started using the device. So here we've got information about what version of the iOS software that it's using. We're using iOS 15.1. It has some information about what feature sets are installed on this device. And then the configuration register, which is normally 2102. This is a hexadecimal. The 0x is an indicator that's a hexadecimal value and not a decimal value. There's no A, B, C, D, E's, and F's in it. You can't tell for sure, but the 0x tells us this is hex. We will be using that in a later course to learn how to perform the password recovery procedure on a router. And we'll do it on switches too. So that if, for example, a company's administrator, network engineer leaves and he didn't know the password, they didn't write them down, you can go and reset the password on the device to some. You don't care what the last password was. You just want to set it to a device, to a password that you know. Exactly the same thing is done with Windows servers. If the Active Directory administrator leaves and no one knows what the password is, but I get up close and personal access to that server, I can reset the password to something I know, like the enter key. Okay, standby one now. I'm going to bring up this other lab and show you guys how to do the serial, install this serial port business. So hold on, I'll pull up that other lab. And where did it go? And let me stop sharing this for a moment and show you the first page of that lab. This is one of the required labs that you guys are supposed to do and turn into me via email as a saved Microsoft Word document. Okay, the two labs, I think I have the exact same wiring topology. The only difference is in this first lab, you do the IP version 4 static routes. And then the second lab, you do IP version 6 static routes. So here's the deal, guys. These routers come from the factory with no serial ports. These days, serial ports are getting kind of long in the tooth. We would normally use a serial port attached to the old T1 lines and ISDN lines and things of that nature. Normally these days we attach to an Ethernet handoff device. Like your home router, it doesn't have any serial ports in it. It has a RJ45 Ethernet port to plug into your cable modem or your telephone company modem. Okay, I'm going to stop this and now bring up the packet tracer again, and I'll show you how this works. So where's my packet tracer? There it is. Share it. And I'm going to put this lab away and start a new lab. Okay, so on our topology, we have 2 routers and 2 switches and 2 host PCs. Pardon me. So I'm going to do this in the same order that it is on the same spacing he has on the front page of the lab. So I'll click on Network Devices. I'll choose our 1941 router, and there are 2 of them. Then I'll choose 2 of our 2960 switches. There are 2 of them. And then I'll choose 2 PC host machines and put them in there. And I'm going to squish these up a little bit here because I'm going to expand this thing because the print is kind of tiny. There we go. That's a little bigger. Okay, in the scenario for this lab, here's the deal with these routers. When I just click on the router by itself, I get the physical picture of the router, and it doesn't have the serial card in it. So I need to actually turn off the power here. I've turned off the power. If you try to do it with the power on, here's what happens. I'm going to put this hardware card in here, and it's going to say the power is on. You're not supposed to add a hardware card to a device when the power is on. You're supposed to turn it off first. So I'm going to switch it off, and then I'm going to put this serial port right in. And it took it. Better turn the power back on, or we'll have a physical layer problem. Now that router is configured, and if I float over it, it should tell me here that it has 2 serial ports and the 2 Ethernet ports. Now let's look at the other one. We haven't done the other one yet. It only has the 2 Ethernet ports. So I need to do the same thing on this one. I'm going to click on it, turn off the power, drag the serial port over to the device, and turn the power back on. And if we go to the CLI, we can actually see it boot up like it normally would. When you reload the router or reboot the router, you get this tic-tac-toe progression as it's unloaded and put into there. Okay, we already went through going into the switches and make sure they're erased. Anytime you bring up a new switch in Cisco Packet Tracer, it's erased. No previous student cannot have accidentally left a configuration on it. So I'm not going to go through that again. We've already covered that. So let's do the connection thing here and see if we can get this connected as shown in the first page of the lab. So I'm going to click on the jagged lightning bolt thing. Oh, I better click on the router first. Okay, click on the lightning bolt thing, and I'm going to do the Ethernet connections first like we did before. The question, thank you. The question is, do we want to, when you finish the labs, I prefer you to email them to me directly to my email account so that they can get them properly. And I have not set up a facility yet in Blackboard for accepting those. So please email them to me at mark.hicks@tcc.edu or william.hicks@my.tcc.edu, and I'll get it either way in that case. Thank you. Thank you for that question. Okay, we're going to make the Ethernet connections, and I'm going to click on router, the first router, and it says use the G01 connection. And that's going to go to the switch port number 5. And then I'll also click on the Ethernet connection one more time and connect switch port number 6 to the PC's Ethernet port. And I'll go back and do PC. It's PC/A is what the lab calls this one, and PC/C is what this one is called. I'm going to connect the PC/C to port number 18. And then I'll connect port 5 of the switch to G01 of that. Now, we need to do this point-to-point serial connection. And he tells us to use this particular scheme. We're going to go into, oh, sorry. We need to go to the I want to connect to serial 001, and that goes to serial 000 of the other router. Now we've completed the serial connection. In our laboratory here at the school, what we've actually got is those dark blue serial cables that are pre-wired in this configuration. Okay, so that shows how to do the secret thing with connecting the serial ports in R1 and R3. You've actually got to go into them to the device. Oh, you stop that. You've actually got to go into the device and go to the physical screen and turn the power off and drag the switch in and drag the module in and then turn the power back on to make that complete, to work properly in the labs. Now I want to go into, let's see now, this is the chapter 2 lab, and it's covering the static routing. When we connected those first lab, we connected those two PCs together. They were directly connected to each router port, and routers are perfectly capable of routing between directly connected interface ports like the 2 gigabit ports, without you having to type in any routing, dynamic routing protocols like RIP or OSPF, or do any static routing commands. But when we're in a scenario like this, PC1, PCA, and PCB in the first lab were directly connected to one router that was right between them here. And they pinged each other, and I didn't type in any commands. I didn't type in any dynamic routing commands. I didn't add any static routing commands. So in this scenario, after the first router is configured with his IP address for this Ethernet port, the PC will be able to ping his default gateway of that router fine. But he won't be able to ping the other router or the other PC because that information is not yet in his routing table. He will need to put a static routing command in for that to work. So let's see now if I can just put in some simple commands here and make this work. PCA, packet tracer, come back to me. Okay, PCA, we'll go to the configuration. And the default gateway for PCA was 192.168.0.1. And his actual IP address was 192.168.0.10, regular subnet mask. And PCB, his default gateway, I'm sorry, PCC in the lab, 192.168.1.10. I'm sorry, 1.1 is the default gateway, 1.1. And then the actual IP address was 192.168.1.10. Since these devices are directly connected, they should, well, I haven't configured the routers yet. They won't be able to ping anything. Let's place a simple configuration on the router as well. So I'm going to go to router R1 and go to the command line interpreter, and it looks like it's erased and has no configuration. And when we type the command show IP interface brief, everything's administratively down. Let me make this a little bigger. so we don't wrap. So I'll go to the privileged exec mode, and then I'm going to go to the interface on R1. I'm going to go to the configuration mode, configure T, interface, gigabit 0/1. This address is given as 192.168.0.1 with your standard 255.255.0. Oops. IP address. IP address 192.168.0.1 and 255. And I'll do it no shutdown. Now I'm also going to put an address on the serial port to give communication to the other router. So I'll say, let's see, go back to configure terminal, interface serial 0/0/1. And the IP address we've been told to use is 10.1.1.1, but look at the subnet mask. 255.255.255.252 or a /30. Very efficient, small network that only has 2 usable addresses. Great for a point-to-point serial link, point-to-point link between 2 campuses or locations. It doesn't waste too much of addresses. And I'll type a no shutdown. It's not going to come up and up really well until I do the serial port on the R3 router that's to his right. So let's go to that router and configure it. Okay, we're on router R3. I'll go to the privileged exec mode, go to config T. I'll give him a host name. I think I forgot to give the other router host name, R3. And we're going to give R3, we're going to go to the interface gigabit 0/1 and give them an IP address of 192.168.1.1. Do a no shutdown. And then I'm going to give the serial port on that is appropriate address. So let's see, go back to the user privilege exec mode, config T, interface, serial 0/0/0, and the IP address is given as 10.1.1.2, and that /30. Do no shutdown. Now let's check with show IP interface brief. And it looks like our serial port is up and up. Let's do a quick test from R3 and see if we can ping the 10.1.1.1. And it works. Oh, good, it works. Let's do a quick check from R3 and see if we can ping our PCC, which is over there at 192.168.1.10. And this is just ARP. Yeah, it worked fine. It's working just fine. When we do the pings on the PCs, you get reply, 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 reply. When you do the pings on the routers, you get exclamation, 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 exclamation. Let's try the same thing on router R1 and see if he can talk to his directly connected guys. Okay, so I'll bring this over here. If we do, oh, I'll give him the host name. Let me go to host name so we don't get confused here. Configure T, host name, ho R1. There we go. Now, if we do a show IP interface brief, we can see that the gigabit port is up and up, and the serial port is up and up. And can I ping my own PCA that's attached to me? Wasn't he 192.168.0.10? And it's fine. The first failure, first dot or two, the dot is no reply at all, and the exclamation point is reply successful. And I could ping the serial port from R3 to R1, I surely can I go back and ping the other way? So that's going to be the 10.1.1.2. I can ping them just fine. Okay, quick review. Let's just show the IP routing table. We have our two directly connected networks, the 10.0 network and the 192.168 network. We do not have the 192.168.1 network in this routing table. So if I tried to ping 192.168.1.10, the PCC, I cannot ping it. There is no entry in my routing table for 192.168.1 network. I can't get there. There's no way to get there. Normally we would use a dynamic routing protocol, but today we're going to use a static routing protocol to put that in there so that we can see it. I also cannot ping TCC's default gateway router, the gigabit Ethernet port on the second router, the router R3. So let's fix that problem on both these routers. I'm going to put a static routing command on both routers so that they can talk to each other. So I'll go to the configuration mode, and you'll see some more detail about this in the when you go through those slideshows, those YouTube videos I posted of some presentations on Chapter 1 and Chapter 2. There's nothing in the routing table. I don't want to do a dynamic routing protocol. We're going to do RIP a little bit later in the semester, and we'll do OSPF in a later curriculum. So what I'm going to do right now is I need to put a static routing command in there. So the command is IP route to create a static route. And I'm going to do a really tricky thing that you can do when you have networks that only have a point-to-point network. Let's pretend that this network is the South Campus network. And let's pretend that this network is the district headquarters. We're on a stub network. Our only way in and out is this leased telephone line that takes us back to the company headquarters. So I want to put a command that says any possible IP address that you encounter that you can't find here locally, my 10.1, my 192.168, send it to the home headquarters and he'll find it for me. And I'm going to do the same thing on this router. Any address you see that's not on this site locations, send it to the other router. So the wildcard, there's a wildcard statement in here, not a wildcard. In the DOS, in the Windows command prompt, if you type delete star dot star, the star dot star matches everything. If I said delete star dot star, all files would be deleted regardless of how they're spelled. In the IP world, the equivalent is a 0.0.0.0. It's a special reserved IP address that matches everything. So I want to tell the router all the addresses that aren't already attached to this router, and they're in another location. I want you to send them to the serial port to my home headquarters or to your ISP or whatever. So 0.0.0.0, any IP address, 0.0.0.0, any subnet mask. And I want you to send that to the serial, what's my serial number here? From R1, it's serial 0/0/1. So that's telling if you encounter any IP addresses that you don't know about, pump it out the 0.0.0.1 port. And now when we look in our routing table with the show IP route, we see a new entry. This is a static route. It's a special case of a static route called a default static route because it handles all addresses by default that are not explicitly listed in these other lines. And the words up here change from gateway of last resort has not been set to telling us that that has been set. Now, I've only done it one way. I've got to do it on the other router because if I send my ping now, it will be delivered to router R3. But router R3 doesn't know how to get back to me yet. So I'm going to go to router R3 and do a similar command. Okay, router R3, we show IP routing table. It says gateway of last resort has not been set. It has no knowledge of how to get back to R1. If I try ping, it would know how to get there. It would drop the packet. So let's put that in there with configure T, IP route to any unknown network and any subnet mask, and the serial port number 0/0/0. Now when we check our IP routing table again, it's in. So theoretically, I should be able to ping, PCA's address. PCA's address is 192.168.0.10, and it works. Hey, how about that? Just fine. Now, we should have end-to-end connectivity now. So this is going to be the acid test. I'm going to go to PCA. Bring up the desktop. Bring up the command prompt. Verify our own address. And I should be able to ping PCC, who was 192.168.1.10. And I'm getting a reply, so I have end-to-end connectivity. Just to prove it's working both ways, I'll go to the PC/C. Go to our desktop, our command prompt, configure the verify the current address, and I should be able to ping 192.168.0.10, the other PC. It works just fine. I forgot to unmute my microphone here. Okay, so your assignment is going to be read chapters 1 and 2 on that. Let me bring that chart up again. Share that chart again. Are you going to share? Supposed to share. There it is. A little slow. There's about 10 million students on the Blackboard system all throughout the world today. This is the first day. Pretty much all the colleges have gone back with online learning. Everybody's been kicked off campus. So the Blackboard and the bandwidth is being severely tested, but we seem to be doing okay today. Okay, so I covered the course requirements. I showed a little bit about the Blackboard and the Blackboard Collaborate, and most of you guys in the class have managed to connect to Collaborate okay. After I finish this session, I'm going to turn on the open room again, and if you ever want to meet with other students, you can have them collaborate with you in Blackboard, and you can share your screens, and your microphones will be over, so you can have all the feedback and the echoes you want to. I just have to stop it while I'm lecturing here. So please read chapters 1 and 2 in the NetAcad. Please look at the recorded lectures that I placed in the recorded lectures portion for chapter 1 and chapter 2. I've got 2 different guys doing the lectures for both chapters there. Look at one or both of those. And start working on these labs 2.2.2.5, which is the IP version 4, static routing, and labs 2.2.4.5 in Packet Tracer. All of the chapter assessments are on now for all 10 chapters in the curriculum. Don't try not to get too far behind on all those, or you might feel overwhelmed. Okay, Mark's going to stop talking now and turn off the microphone, and I'm going to keep monitoring the session here in case anybody has any chat questions or anything of that nature. I still will be maintaining all my office hours every day, and the best way to get in touch with me is to send me an email at my email address is posted on the ICR, and I normally get back to you pretty quickly on that. Okay, thanks guys. Enjoyed meeting with you guys today. Look forward to seeing you guys again on Wednesday at 9 o'clock for our next online lab session.